Hi guys, in my last lecture we had taken shear forces and bending moment in beams, but that was for simply supported beam and with point loads. Now here in this class we will be discussing the numericals on simply supported beam with UDL. Now we have a question here, like a simply supported beam of span L is carrying a uniformly distributed load W over the entire span. Calculate the SF and BM and also the SFD and BMD. Now what we do here is we convert this into a point load. How do we do that? We take up this is here we have RA, here we have RB, the reaction, and this will be converted W into the whole length, so WL, and it will act at L by 2, L by 2. Okay, now let us calculate the summation of Fy. Summation of Fy is equal to 0. So that is RA minus WL plus RB is equal to 0. So we can write RA plus RB is equal to WL. So this is equation 1. Summation of MA, moment about A, is equal to 0. So minus WL multiplied by L by 2 plus RB. This WL is acting in this direction, so WL minus L by 2 RB multiplied by L. Here what we have taken is clockwise as negative and anti-clockwise as positive. So therefore RB could be written as WL by 2. Okay, so from this what we get is RA. We put this value in this first equation, RA plus RB is equal to WL. So RA is equal to WL minus WL by 2, that is the value of RB. So RA is equal to WL by 2. So here we can write this is WL by 2. This is also WL by 2. Okay, we leave this space for the SF and the BM. Now we do the rest of the calculation. We will take up the shear force. Calculation. Summation of SF. What we do is we first take a section, that is XX section, which is at a distance x from A. So we will first calculate SF at XX section. So SF at XX section is equal to WL by 2 minus W into X. Now at X is equal to 0, that is at A if we are coming to A, then X becomes 0 because this section shifts over here. So therefore, SF A is equal to WL by 2 only. At B, X is equal to L. So therefore, SF at B will be equal to WL by 2 minus W into L. In place of X, we are writing L. So which is minus WL by 2. Okay. Now we will take the bending moment calculation. Now summation of BM at XX is equal to, for BM at XX section, what we have here WL by 2, and here also we can write WL by 2, and this is for XX section, so that is for X distance, and for this distance W, which is acting in the anti-clockwise direction, is W into X, this distance, multiplied by the half of this distance. Half of this distance is X by 2 because it will act at the center of this section. So we can write WL by 2, that is acting for the whole section X, minus W into X, that is the UDL being converted into point load, and the distance is X by 2, which is equal to WL X by 2 minus WX square by 2. Now at A, X is equal to 0. So therefore, BM, bending moment, at A is equal to, here also we have X, here also we have X, this comes to 0. Now at B, X is equal to L. So BM, B will be equal to WL by 2 multiplied by L minus WL square by 2, which again comes to 0. Now we have to find out where BM is maximum. BM max is where SF is equal to 0, occurs where SF is 0. Therefore, summation of SF at XX section is equal to 0. So SF, from this formula we will find that WL by 2 minus WX is equal to 0. So from this we get X is equal to L by 2. So here we have the maximum BM. So therefore BM max is equal to, we will put in this only, WL by 2 multiplied by, here for X we will put L by 2 minus W by 2 into L by 2 whole square, which is equal to WL square by 4 minus WL square by 8. which is equal to WL square by 8. Okay. Now we will draw the SF, the BM. Here we have WL by 2 and it will cross over at L by 2. This is positive. And here we have again WL by 2, which is negative. It is crossing over at L by 2. For the BM, we have the maximum point at here, this position. It will be a curve where BM is 0 and this is 0. This here also we have 0, and at the maximum point it is WL by 8 that we had seen, WL square by 8. WL square by 8, and this whole curve is positive only. So this is our SFD and this was our BMD. Okay. Now we will take up another problem. Here we have draw shear force diagram and bending moment diagram for beam loaded as shown in the figure. We have the figure over here. Now similarly, we will convert this into point load. This is RA. At 2 meters, we have this 20 kilonewton. Another 2 meters, we have the BMD is, UDL is starting. So we have here, say 2 meters, and this will be at the center of this. So this will be 10 multiplied by 4, that will be 40 kilonewton. It will act again at 2 meters. And 2 meters from here, we have RD. This is our C point, this is our B point, this is A point, and this is D point. Now, what we will do is, we will take moment about A is equal to 0. That is 20 minus 20 multiplied by 2 minus 40. Here also what we are doing is, this is negative and this is we are taking as positive. Minus 40 multiplied by 6 plus RD multiplied by 8 is equal to 0. Therefore, 8 RD is equal to 40 plus 240, which is equal to 280. Therefore, RD is equal to 280 by 8, which comes to 35 kilonewton. Now, summation of Fy is equal to 0. So in Fy we have Ra as positive, Ra minus 20, it's coming down, minus 40 plus RD is equal to 0. So RA is equal to, this becomes 60 minus RD is 35, which is equal to 25 kilonewton. RD is 35. So now we can take up the SF calculation. SF calculation. SF at A, L, we will take to the left hand side of A. There is no force on the left hand side of A, so that will be 0. SF on at A, right hand side. Right hand side we have got RA, so that has to be considered, that is 25. Then SF at B. B, till B we do not have any other force, so till B left will be 25 only. SF at B R, right hand side, we have 25 minus this 20, minus 20, so it comes to 5 kilonewton. Now we will take up SF at C. SF C L, left hand side. Till left hand side C, till C, this force is continuing this. So we will have 5 kilonewton only. Then SF C, right hand side. Right hand side, what we have is 5 minus 40. We will take this point as C, not this point as C. So that is equal to minus 35 kilonewton, and SF D left, that is minus 35 will continue. SF at D R, that is equal to minus 35 plus 35, that is equal to 0. Now we will do the BM calculations. BM at A is equal to 0. BM at B is equal to 25 multiplied by the distance. This distance is 2, so it will be multiplied by 2, which is equal to 50 kilonewton. Now BM at C, which is equal to 25 multiplied by 4 minus 20 multiplied by 2. We will see that. (25) multiplied by 4 from here, this distance, and 20 multiplied by this distance from C. Now, which comes to, this comes to 60 kilonewton. BM at D is equal to 25 multiplied by the distance 8 minus 20 multiplied by 6 minus, this is 40 multiplied by 2. 40 multiplied by 2, which is equal to 0. Now we will have to calculate the position where SF is equal to 0. Position where SF is equal to 0. So SF is coming down is 25, therefore 25 minus 20 minus 10 suppose it is cutting at x, so this will be 4 minus x, or x minus 4 rather, x minus 4 is equal to 0. Therefore 5, this is 5 minus 10x plus 40 is equal to 0. Therefore 10x is equal to 45. Therefore x is equal to 4.5 meters from A. Now maximum bending moment. For this, 25 multiplied by x minus 20 multiplied by x minus 2 minus 10 into x minus 4, and this will be acting at x minus 4 by 2. So this becomes, for x we will put 4.5. So 25 into 4.5 minus 20 multiplied by 4.5 minus 2 minus 10 by 2 into 4.5 minus 4 whole square. So if you calculate this, this comes to 61.25 kilonewton meter. Now we will draw the SFD and BMD according to what points we have got. Now here we have 25, this point it comes down to, this is 25 kilonewton, and this is positive, and here it comes down to 5, and here it comes down to minus 35, so 5 kilonewton, it crosses over, and here this distance is 4.5 from A, where it crosses over, Here also it is positive. Here it is negative. Now this is our SFD. Same way we will be doing the BMD. BMD, here we do not have, we have point load, so it is a straight line. Then till here, till this portion, we have here it is 50 kilonewton meter. Here it is 0. Here we have 60 kilonewton. And then we have this curve, which is at the highest point. Here it will be a curve, parabolic curve. Why? Because for BM, what we have is, it is in x square. Here it is, the square is there, the square is there, so that is why it will be a curve. The highest point is 61.25 kilonewton meter. And this whole thing is positive only. Last problem also we had seen that when we are calculating BM, we had seen that it is WL by 2 into x minus W by 2 x square. Because of this x square, we get this parabolic curve. So here also, same time, we are getting a parabolic curve. Now, that is all for the UDL with simply supported beam. Now, next class, we will be discussing UDL with overhanging. Thank you so much.